Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome, focused learners, to this explainer. Today, we're jumping right into a quiet, but honestly massive technological shift that entirely shaped the personal computer as we know it today. We are talking about the dawn of a completely new discipline, one that revolutionized how we actually interact with our tech. It's this fascinating historical journey of how machines literally had to adapt to us rather than the other way around. Now, I want you to just imagine something for a second. Why wasn't a 1970s mainframe computer as easy to use as, say, a household vacuum cleaner? I know, it sounds like a slightly ridiculous question to ask today, but back then, everyday people were suddenly confronting these incredibly complex machines, and honestly, they fully expected them to work just like simple household appliances. You know, you plug it in, you turn it on, and it just works. No PhD in electrical engineering required to vacuum your rug, right? But as we know, early computers were anything but simple, and that exact expectation set the stage for a pretty massive collision. Okay, let's dive into this with Section 1, the 1970s usability crisis, a computing shift. So between the 1970s and the 1980s, we saw this massive physical computing shift. Before this era, computers were basically these giant, room-sized mainframes locked safely away in research labs. But then, they started migrating. First, they transitioned into offices as mini-computers, and then the real revolution hit. They actually entered our homes as microcomputers, becoming genuine personal tools. Think of iconic machines like the Apple II, the IBM PC, or the Commodore. Suddenly, you have a computer sitting right there on a desk in the family living room or a small business office. But here's the catch. The real issue that accompanied that physical move was the massive user shift. On one side of the coin, you have your original users, the engineers and scientists with deep technical expertise. They already knew how to speak the computer's complex language. But on the flip side, you have this entirely new wave of users, non-technical people, trying to use these machines for work and personal tasks, but with very limited training. These new users absolutely required systems that were intuitive. Like we mentioned earlier, they quite literally expected the simplicity of a stove or a vacuum cleaner. The stakes here were incredibly high. The risk was actually pretty simple. Without an intuitive interface, the entire personal computer revolution was doomed to failure. It really was. If non-technical users couldn't figure out how to operate them easily, the whole movement would have just ground to a halt. These incredible machines would have just gathered dust in homes and offices simply because they were too frustrating to operate. The hardware was totally ready, but the human connection, that was entirely missing. Which brings us to Section 2, defining human-computer interaction. A new discipline. So HCI emerged as the necessary hero to save the day. We have a formal definition here, and it's a powerful one. Human-computer interaction is a discipline concerned with the design, evaluation, and implementation of interactive computing systems for human use and with the study of major phenomena surrounding them. Now notice that absolutely crucial phrase right there in the middle, for human use. This brilliantly captures the deliberate shift away from making the human adapt to the machine, and instead forcing the machine to be built specifically around human behavior. But getting to that standard of human use, well, that wasn't a job for computer scientists alone. The massive spread of personal computers into daily life, at home, in schools, in workplaces, it required a totally new approach. So HCI became a truly multidisciplinary field, pulling together four very distinct pillars. You've got computing, psychology, design, and ergonomics. You obviously needed the computing code, sure, but you also needed psychology to understand human cognition, design to create clear interfaces, and ergonomics to ensure the physical strain of sitting at a screen was actually accounted for. It really became a multidisciplinary powerhouse. Moving right along to Section 3, core goals of HCI, the daily objectives. There are four main practical objectives here that create a really fascinating life cycle for this field. First up, researchers and designers have to understand the human-computer characteristics that actually affect the interaction. Second, they need to adopt suitable usability engineering lifecycle models. Basically, this means building a structured, repeatable process for making things usable. Third, we actually get to designing the user interfaces, and we do this specifically through prototyping techniques. And finally, the fourth goal, evaluate those user interfaces. It's this continuous narrative loop. You understand the user, plan the lifecycle, build prototypes, and then test them to evaluate the results. Let's look at how that's done in Section 4, Prototyping and Interface Tools. Building interfaces. Now, what's really interesting about this slide is how the goals of HCI directly dictate the specific tools students and professionals use in the field. They are designed to facilitate prototyping, interaction design, and usability testing. They are explicitly not built for artistic or print layout design. The purpose isn't just to make things look pretty or visually striking like a magazine layout. No, the purpose is entirely to support interface evaluation and rapid iteration. Because of this focus, when you're taking an HCI course, the goal is never to just learn a piece of design software. Instead, it's about step-by-step application. Step 1. Students apply usability, interaction, and user-centered principles. Step 2. They use tools to build prototypes and mock-ups to bring those principles to life. And Step 3. They conduct visual experiments. The software is really just a vehicle to step-by-step apply interaction design principles and see what actually works for a real human user. And finally, Section 5, Internal versus External Workings, the software focus. So, the crucial point is the clear difference in focus between traditional software engineering and HCI. Software engineers focus heavily on the internal workings of the software. They're building the hidden architecture, the logic, the back-end systems. But in HCI, specialists are concerned strictly with the external workings of the software. They command that human-facing exterior. Basically, if the software engineer builds the engine of a car, the HCI specialist designs the steering wheel, the pedals, and the dashboard so a normal person can actually drive it safely. Which leaves us with this final provocative thought to wrap up the explainer. We've seen how back in the 1970s, failing to prioritize non-technical users and ignoring usability literally risked dooming early personal computers to total non-use. The industry had to invent an entirely new discipline just to survive. So I challenge you to look around at the tech landscape right now. What modern technologies are failing today simply because they ignore the human on the other side of the screen? Keep that in mind the next time you use a piece of tech. Thank you so much for joining me for this explainer, and I really hope this helps you see the screens around you in a whole new light.